Okay, we finally got that 15th person in, looks like. Right? Correct. There we go. Good. So we got like 5 people at school and like 10 people at home, right? Wow. And y'all all started at school together because y'all were all sitting around the table. Okay. Anybody got the flu? Oh yeah, that flu's gone. It disappeared. All right, so we're talking about 1.4. And y'all said that's where we left off, 1.4. Yeah, Hubert, that's where we left off. Okay, class, thank you. It's always nice to have a class to communicate with you. And nothing. Y'all do this to all your classes, all your teachers, just not talk, or what? Unless I talk about something other than math, and then y'all will talk my ears off, right? No. Y'all suck. All right, 1.4. Did we talk about stratified and cluster? I thought we did. I thought we covered 1.4. Okay, so whoever said to do 1.1 through 1.4 homework, that was right. So let me move over to 1.5. Did we talk about bias? Okay, nobody says anything.
Okay,
so say again?
We didn't.
I didn't think so. Okay, so we're going to move to 1.5. And that's the last section in the chapter 1 material. So that means that you should have chapter 1 done. Now, I don't know why people don't like this this subject, but I'm sorry, it's in the book, so I'm going to cover it. We had a student, did I tell y'all the student that complained last semester? Complained that I was talking about bias in statistics. And my department head went, what's wrong with that? Well, I don't think he should be talking about bias. It's in the freaking book. Anyway, I'll let y'all figure it out. I ain't never heard of not talking about bias in a trying to get my whiteboard to work. There we go. In a statistics course. Can anybody think of why? I don't know why you fuss about that. All right, bias. Can anybody give me a layman's definition of bias without looking at the book? Anybody? Give me a layman's definition of bias. All you got to do is unmute your mic. That's all you got to do. One-sided, preference towards one thing over another. Good. How about pushing an agenda? Pushing your own beliefs? Yes or no? Yes. Remember, Mark Twain said there's lies, there's damn lies, and then there's statistics. In other words, you got to be very careful when you're dealing with statistics. What do you mean? Well, do you remember me telling you that the good thing to have with statistics is uniformity? You remember me saying that? Uniformity. Well, what's the opposite of uniformity? Bias. So you can't have one without the other. If you have uniformity, you won't have very much bias unless you interject it yourself. Bias can be done 3 or 4 different ways. LAD, which is lazy attitude disorder, by mistake, or intent. And unfortunately, a lot of the times you're talking about intent. I don't know if I showed you this, but I'm going to show you anyway because I don't want you to think I made it up. Mark Twain statistics. There you go. There are lies, damn lies, and statistics. Now, do you have to be careful of bias as an observer as well as a presenter? Yes or no? Yes. You know, there's an old saying that says ignorance is bliss. Okay? In other words, sometimes people like to be ignorant because they don't want to ask too many questions. Well, when you're given a presentation and you're watching a presentation and you see bias, that means that the presentation is not worth, you know, what it's written on, what the paper is written on. Same thing if you are biased with your research. Can y'all give me some examples of being biased? Anybody? I had the Crescent group give me some good examples yesterday. Anybody? I'm waiting because you ain't going to get by with just sitting there. You're either going to give me something or your political parties. Yes? Very biased. Give me another one. Now, the Crescent group gave me 4. Are you telling me that you're gonna let Crescent outdo you? They gave me 4 examples. Whether you're for or against the vaccine. Yeah, you could be biased about that. Yes. What else? News channels and the media. Yes. You're starting to give me one more so you can at least tie Crescent. They actually gave me one that I forgot about. Whether you're for one football, exactly, ESPN. That's what they said. Who gave me that one? Miss Bridwell. Good job. Because that reminded me about how one-sided ESPN, I mean, one of the most overrated teams and one of the weakest conferences is Ohio State. And have you ever watched a game that had Ohio State in it? They could be playing Tampa Bay, which is the Super Bowl champions. They could be playing Tampa Bay, and the ESPN announcers would say that Ohio State was going to win the game before they even got to the field. Okay? Now, am I crazy or am I not crazy? Okay, I'm not crazy. I see a couple of people. And the same thing with other strong teams, very strong teams in weak conferences. I don't know why they do that. I don't know why they try to build them up. But you get a strong conference and a not so strong team, and they don't even talk about it. So you're right. ESPN is a good example, or news commentators, or whatever you want to call them. So With LAD mistake, let's give an example of LAD. A quality assurance manager not pulling enough samples. Okay? A quality assurance manager for a big company not pulling enough samples can sway a presentation. News reporter giving a good story, in other words, they did their job, to graphics in a, let's say, a newspaper or a magazine, and the graphics people mess up the report by putting bad graphics on a report. You ever seen like a graphic with a big, like let's say an oil barrel, OIL, and then a small barrel, and it's way too big? That is an example of the story is good, but the graphics messed up the story. That's by mistake. In other words, they didn't know better. And then intent, that's pretty much self-explanatory. Bias is to statistics as you could say sand is to glass. Or you could put anything in there. Bias is to stats as sand is to glass. Or you could say sugar is to gasoline. Okay? In other words, it cancels it out. You can't have bias and in statistics. Now, where can you see bias in statistics? The questions you ask. How can a question be biased? Somebody speak or type it in. How can a question be biased? I'm waiting. All you got to do is unmute your mics. I mean, COVID doesn't give you laryngitis. Okay, we're just going to sit here and stare at each other. I'm not going to have a class that does not communicate, so we'll just sit here and stare at each other. Good job, Miss Newsom. It is obvious what side the person asking. Would you say a leading question? Leading? Maybe a leading question like, why do you hate the current blah, 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 blah? Okay, you should not put negative or positive comments in a question. Never. Should you have open or closed questions? Open. I'm sorry. Closed. You should have closed questions. Now, if you want to have a closed question and then explain, that's fine. But most of your questions that you have in a survey, you should have closed questions. The research and calculations. I knew one person that did a research project, and they sent out the survey, and they counted no response as input. You can't do that. You cannot count a non-returned survey as, well, they don't like what I'm talking about. You can't say that. You ever had your parents tell you what you're thinking? Nobody has had parents tell you what you're thinking. How irritating is that?
Yes.
Is it irritating? The same thing with bias. It's irritating when a researcher takes on the role of thinking like the person they're researching. And the last thing, interpretation. Interpretation. You cannot be biased with the interpretation. If the interpretation says the sky is blue, then you have to report the sky is blue. This is where we have some problems with what you're talking about. Some of you said sports anchors. Some of you said media. Some of you said parties. That's where we have the problem right here. And they say, you know, you could have a jam-up football team, but Ohio State's going to beat them. You know, doesn't matter who they play. And that's pretty much it with bias. Now, everything I wrote down here and here basically are test questions. Now, how do you know what they're going to ask? Well, you just read 1.5. I've covered the hot spots. Question, gripe, complaint. Did I make y'all mad or something? Did I do something in the last class to make y'all mad? Because y'all talked in the last class. What happened? Somebody get mad? Are y'all not allowed to talk? What's the problem? Mr. Hamby, help me out, man. You're tough. Hamby, tell me what the problem is.
I'm pretty sure we're all just tired.
You tired?
Yes.
Okay.
Okay. All right. Well, I'll accept the tired excuse for today. Mr. Dickerson, are you tired too? He didn't even respond. Where's Miss Bridwell? Are you tired?
Yes, sir.
Okay. All right. I'll take that excuse. All right. 2.1, 2.2. We're going to be discussing frequency distributions. Why do I say it funny? Because you know what a frequency distribution is, but in statistics, you can't call it what it is because in statistics, you got to be fancy. And a frequency distribution is nothing but a what? A table or a chart? A table or a chart? In 2.1, we talk about qualitative. Here is a qualitative chart. Blondes, brunettes, redheads. 2, 4, 1. That is a qualitative chart. In 2.2, they talk about quantitative charts. Which doesn't have categories. Anybody know what goes on the left side of a quantitative chart? It's not categories, but it does start with a C. How many of you have been involved with wrestling? Not wrestling on TV, but wrestling, boxing, and any type of martial arts? What are they divided up into? Oh, come on. Are you telling me that none of y'all have been involved with any of those things, or y'all just not want to talk? What are they divided up to? Thank you. Good God. I mean, you can at least freaking type. (20 to 24, 25 to 29, 30 to 34, 35 to 39, 2, 4, 6, 8. Miss Ferguson, are you tired too?
Yeah.
Why is everybody tired? I don't understand. I can't even see Mr. I can't even see. Is it Miss Webb? I can't even see you. She's in the dark, or he's in the dark. I can't. I guess that's she, isn't it? The Felicity, is that correct?
Yes.
Okay, I can't hardly see you. I mean, because you're in the dark. I just want to tell you you're in the dark. Miss Poor, how are you today? They can't talk.
I'm fine.
Okay. We're gonna communicate. I don't care if it kills y'all. We're gonna communicate. You're not gonna be that date that goes to the restaurant and orders the carrot with the water. You're not gonna be that person. All right. Miss Landreth, how are you today?
I'm fine.
Are you tired too?
Yes.
What are y'all eating and drinking up there? Are y'all just all work third shift? What's the deal? Let me guess. You're like my son. You go to bed at midnight and you wake up at 6 and then wondering why you're tired. Well, I personally call him a dumbass for doing that, because he's not going to sit there and say, I'm tired. Well, What time did you go to bed last night? So, I'm sorry. What time did you go to bed last night, Miss Landreth?
11:30.
And what time did you get up this morning?
6:30.
And what's 2 plus 2? 746. Okay? If you go to bed at 12 o'clock and you get up at 6, by the time Thursday rolls around, you're going to be tired. Okay? All right. What can I give you for these, for the qualitative? What can you give me as far as a question? Well, relative frequency. Does anybody know what relative frequency is? It's a percentage. But you can't say percentage in statistics. You have to say relative frequency of the frequency distribution. You got to be able to read a bar chart or a pie chart. And you've got to be able to make a bar chart. So for qualitative frequency distributions, you've got to be able to do those three things because that's the only thing you can do with a qualitative frequency distribution. You can't find the mean and the standard deviation. That's a test question right there. Find the relative frequency. Okay, I'm going to find the relative frequency. Here we go. Relative frequency. 2 divided by 7. 4 divided by 7. And 1 divided by 7. Now, your relative frequency, depending on, and I'm going to write this up here in red. Your relative frequency depends on your directions. Relative frequency depends on the directions. Whether you have a fraction, a decimal, or a percent. So I put that in red because when you're asked for relative frequency, it may say write as a fraction, it may say write as a decimal, or it may say write as a percent. So make sure when you're doing a question about relative frequency, make sure you read the directions on how to type in your answer. Miss Bowen, why don't you sit by a window? Need some sunlight. I can't say anything. I got windows all through my house. In fact, I wish I had not put all the windows I put on the back of my house because I have to replace them. Okay. Fun teaching a class that don't talk. It's probably the highlight of my day, teaching a class that does not communicate. Make sure you can read a bar chart. Make sure you can, if I give you a bar chart, let's say that's 4, that's 8, and this is 2, and that's 6. Okay? So that's 4, that's 8, that's 4, and that's 2. So 4 plus 8 is 12, 16, 18. So N is equal to 18. That right there is a test question. And there is a question on my test that will ask you to read either a bar chart or a pie chart. Here's a pie chart. 40%, 15%, 15%, and I know it's not exactly correct, 30%. All right. Hold on just. My mother, she knows I don't know why she's calling me. Evidently something's wrong. All right, so 40 and 30, 70, and then 15. So if N is equal to $100, if you've got $100 and 40%, of course, now is fuel. Used to not be that way. A year ago, it was less than that. Then $40 goes to fuel. And $15 goes to food. And $15 goes to, I don't know, entertainment. And then $30 goes to, I don't know, rent, whatever. Okay, make sure you can read a pie chart. That's a test question. These two test questions right here. Okay.
You have a work email.
Now, hold on just a second. I hate to answer this. Just hold on. Of course, she don't answer the phone when I call her. So anyway, now, so far in 2.1, you need to be able to deal with a qualitative frequency distribution. You should be able to do the relative frequency, read a bar and pie chart, and make a bar and pie chart. And in 2.2, we're going to be dealing with a quantitative bar chart. I'm sorry, a quantitative frequency distribution. So let's rewrite our, go ahead and rewrite your frequency distribution, the one that we use, 20 to 24. Rewrite that, please. I'll be with you in just a second. Thank you for, sorry about that, 35 through 39 and 8. Okay, so what are Anybody know what these numbers are? Anybody know what those numbers are called? Just type it in because you're not going to talk to me. I done figured that out. So, anybody know what they're called? And what are these numbers called? Anybody? Yes, no, maybe, hello? Good job. Somebody actually read. This is your lower class limit. And the yellow is the upper class limit. Okay? Now, what can we get? And I'm also going to cross out the head count. And we're going to start calling that the frequency. And we're going to start calling the head count the frequency. So what can we gather from the lower class limit and the upper class limit? Well, we can find the midpoint, which is usually called X. We can find the class width. We can find the class boundaries. And we can find the mean and the standard deviation. Now, the first one we need to find is the class width. And that is found by subtracting two coinciding lower class limits or upper class limits. Can somebody tell me what coinciding means? Or not coinciding, consecutive. What does consecutive or coinciding mean? What does that mean?
Back to back.
Back to back. That's a good definition. Back to back. Now, also remember, it's always positive. You're never going to have a negative class width. That's like saying a negative distance. Okay, you're never going to have a negative class width. They're always going to be positive. So, what is 25 minus 20? And what is 29 minus 24? They're both equal to what? 5. So the class width is 5. Second, we're going to find the midpoint. Lower class limit plus upper class limit divided by 2. So 20 plus 24 divided by 2 is equal to, well, that's 44 divided by 2 is 22. And then you just add the class width. What's 22 plus 5? 27. What's 27 plus 5? 32. What's 32 plus 5? 37. So there are your midpoints. And then the class boundaries. If you are given whole numbers in your frequency distribution, then you're going to go to the 10th. And you're usually going to use 0.5. If you're given tenths in your frequency distribution, then you're going to go to the hundredths, which usually means 0.95. If you're given hundredths in your frequency distribution, you're going to go to the thousandth, which is 0.995. Now I put that in red because you need to write that down and highlight it, because when you're asked for the class boundaries, you're going to freeze up because you're not going to remember this rule. So somebody tell me what comes before 20. What number comes before 20? Thank you, Miss Woodson. I think, yeah, and Miss Bowen, thank you. So my class boundary is 19.5. And add class width, that'll be 24.5. Add 5, 29.5. Add 5, 34.5. Add 5, 39.5. And that is your class boundaries. Now, I hate to tell you this, but there are some teachers that can explain this to you and lobotomize you. So I'm just telling you, it's not that difficult. The most important thing for you to get is what? The class width. The class width is the most important, because with the class width, you don't have to calculate these guys. And you don't have to calculate these guys. You just add the class width to the first one and then the second one and so on. Are all three of these, four of these? This is a test question. This is a test question. This is a test question, and this is a test question. So with 2.2, you're starting to get into a little bit of math, just a little bit. So now let's do the mean and standard deviation.
Message coming in on secured channel.
So I need everybody to write down the formulas you're going to be using. Give you a minute to write those down. Be right back. I have to get some caffeine in my system, so I drink a half a cup of Mountain Dew or Diet Mountain Dew, because I don't drink coffee, and I don't drink coffee, period, because I don't taste it. So what I do in the wintertime is I drink hot chocolate and I pour a little bit of coffee in it because I can taste the chocolate. I just can't taste the coffee. When I taste coffee, it tastes like hot water to me. So I don't taste it. I guess my taste buds are messed up or something. I don't taste it. But I'm one of these people. I can't drink cold drinks in the winter, and I can't drink hot drinks in the summer. I can't do that. I'm just weird. Okay, y'all got them all down? Yes or no? Somebody tell me something or give me
No.
You don't have them? Okay. And just for y'all to know, if you're ever in a relationship or a business relationship or whatever, communication is key. So hopefully just being tired. If you don't communicate, it's not going to end well. Whether you're in a business relationship or a relationship or just in a classroom, it makes things worse. So I know y'all are growing up in a generation, the Tide Pod generation, that does not believe in communicating, and that's not a good thing. So I hope it is being tired. All right, hold on just a second. I'm sorry. I apologize. My mother has a new phone, and she was calling my son at Westside, and I had to tell her to stop playing with the phone. All right. So anyway, this is the formulas. Does anybody know what the funky looking E stands for? Anybody? Okay. Thank you, Miss Ferguson. Thank you for the communication. And everybody else. Anybody? Does anybody know what the sigma, that's what it's called, sigma. Good try, Miss Bowen, but it's sigma. Capital sigma. Write that down. Capital sigma always stands, and I'll write this down at the bottom for you. Capital sigma always stands for summation in mathematics. Capital sigma always stands for summation, which means what? Add everything up. Oh no, I got the COVID. Capital sigma always stands for summation. Actually, I had the flu and COVID. I tested for flu and COVID in December, and I had 105 temperature, which I always have with the flu. I always get a high temperature with the flu. And this is no joke. I'm telling you I'm telling you this is the truth. The doctor said, well, we tested you for flu and COVID, and you tested positive for both, but we're going to put it down for COVID. And I was like, you're putting it down for COVID, but I have COVID and the flu. Yep. And I looked at him like, why? But I didn't say anything. Anyway, I had it for 2 more days, and then it was gone. They gave me some pills and the flu. They said, you're just going to have to ride out the flu. It could be gone in a week. It could be gone in a couple of 3 days. I said, well, okay. But since I got COVID, anyway. Nobody, nothing, no response. Just anybody had 105 temperature with your COVID? I've had the flu. I get the flu every December. Every December I get it. Because my birthday's in December. That's how I remember. And every December I get it. So I know what it feels like. All right. What else do we know? Well, we know F is the head count. So I'm going to put down here, F is the head count. And somebody tell me what N is. What is N? N is equal to the total head count. And I told you a while ago what X was. What is X? Somebody tell me what X is. Thank you.
Midpoint.
Thank you. Good. X is the midpoint. So let me ask you a question. Can you find everything that you need for these formulas? Yes or no? Yes. Now I'm going to do it on an Excel spreadsheet. The reason I'm going to do it on an Excel spreadsheet is so everybody can see it and I don't go right all over the paper. Okay? And I'll fix the spreadsheet where everybody can see the numbers. Okay? So I'm going to go over to an Excel spreadsheet right now. And we're going to do this. Well, my brain would get in gear. There we go. And I'm going to make it a little bit darker. Because I know there's a diva. I know y'all have a diva in the class somewhere. So I'm going to go ahead and take care of the diva. Make it a little bit bigger. Make it a little bit darker. There. Is that a little bit better? You can see that a little bit better. And I'm going to make the, I like Arial, so I'd use Arial. Okay, so lower class limit, upper class limit, and head count, or F frequency. And let's go ahead and make these. I'm OCD when it comes to being centered. There. I feel better when everything's centered. Some of y'all know what I'm talking about. Okay, so lower class limit. Where is my folder? There we go. 20 to 24. 25 to 29. 30 to 34. And 35 to 39. And 2, 4, 6, 8. Everybody with me? All I did was just transfer everything over to the spreadsheet. Now, there are some things we need to go ahead and get. I think we need N, and I made N yellow. So we're going to put this right here in yellow. And N is equal to the summation of F. Okay. So I need everybody to write that down. 14, 18, 20.
You have a work email.
That's supposed to be 2, 4, 6, 8. Yeah. So I got my N. What else do I need? Well, I need X. And X is, what did I make X? Orange? Let's see if I can get there's a burnt orange. There we go. And that's equal to parentheses, this guy plus this guy divided by 2. And we already calculated those. Everybody with me? So far, we've got, I'll take my red marker. So far, we've gotten our head count, our N, and we've gotten the midpoint. So we got those two. We got the head counts. They're already there. And then all we need to do is start plugging and chugging. So how do we find the mean? We take F times X, add it up, and divide by N, right? F times X, add it up, and divide by N. You got to read the what? You got to read the formula. Don't be one of these people that are like, they look at the formula and they go, I don't know what to do. F times X, add them all up, divide by N. So I've got to multiply F times X. Everybody agree with that? So F times X. F times X, this is my title, and I'm going to do it, equals F2 times 22. And that is my f times x. And what do you do with f times x? You add it up. So take my handy dandy and there is your numerator for your 640. So I'm going to go over here. 640 over, what is n? N is 20, right? And that is your mean. So I'm going to go over here. It'll be 32, but let's go over here and do it. I'm going to go down here and I'm going to say mean is equal to 640 divided by 20. Should be 32. Hey, we got it right. We're smart. So I'm going to highlight that. I'm going to highlight that in something I haven't used. We'll highlight it in an aqua color. All right, what's next? Let's look back at our formulas because our formulas tell us what to do. We just found our mean. Now, what's the only thing we don't have in this formula? We've got n, we got that. We got f. We got x. But what do we not have? What do we not have? We don't have x what?
Squared.
We don't have x squared, so we got to have a column called x squared. So I'm going to go back and I'm going to take a column that says x squared. And we'll put it right here. X to the second power. And that's equal to this raised to the second power. And that goes down like that. And copy this over here. And I'm going to highlight this in purple. I really would like a light colored purple. And I know that's not purple, but I don't foresee. That's kind of a purple right there. There. So let's go over here to our handy dandy. Right here, I'm going to try to fit this in where you can see it. So somebody tell me what n is. N is what? 20. And what is the summation of f times x squared? Oh, we got to do that. We got to do f times. We got a f times x, but we don't have a f times x squared. So I need to go over here and do f times x squared. Okay, I messed up. F times x shift 2. How about that? There we go. And that's equal to f times x squared. And copy that down. And there is that number, 209.80. 209.80. Minus, what is f times, summation of f times x? Summation of f times x is 640. And we're going to square that over n, which is 20, times 19. So I'm going to leave that where you can see it. There's your 20, 209.80, which is that right there, minus 640, right there, squared, over n times n minus 1. So I'm going to go over here, and I'm going to do that. So the variance is equal to, well, let's take this 20, and I'm going to multiply that by 29, 20, whatever, that big BA number. And we're going to minus this number. Sorry. This number raised to the second power. And all that is going to be put over 20 times 19, which is going to be equal to this number minus 1. Okay, now this is the formula. I plugged everything into the formula right here. Variance is equal to, what's 20 times, well, I'm going to do it. 20 times this number, going to be a BA number, minus 640 raised to the second power, all over 20 times 19. Variance is equal to this number minus this number, all over 380. And the variance is equal to this number divided by this number. So our variance is that number right there. Variance equals number right there. Now, what is the relationship between the variance and the standard deviation? Somebody tell me what the relationship between the variance and the standard deviation is.
Just the square root of it.
The square root, or raise the variance to the 0.5 power. So I'm going to go over to my spreadsheet. Standard deviation is equal to this number raised to the 0.5 power. And there are the three things that I could ask you for with a quantitative frequency distribution. And if there's a way to do it on the calculator, I have no idea. I know at the TI-83, TI-84, I don't think there is, but you would have to actually input I think you would have to actually input the midpoint with the frequency, and then you could get these numbers. I don't know. But most of the time, this is done by hand. I'm curious, and I asked the Crescent students this, how many of you that have had probability and statistics has seen this before? Because they've never seen it. Okay, y'all haven't either. Well, you'll get one of these on the test. So make sure you know how to do it. And I picked the easy one. I mean, there's only 4 groups there. 1, 2, 3, 4. And I picked some easy numbers, 2, 4, 6, 8. So, and we'll do another one. We'll do another one probably next Tuesday, because your homework, I think, is going to be due Tuesday on chapter 2. Question, gripe, complaint. Okay, I don't know what. Let me look and see on 2.3, because I don't know what. Let's see, 2.2. Let me go to 2.2.
You have a work email.
2.2, what does it talk about? I think it talks about quantitative. Yeah, quantitative, and they're going to talk about boundaries, all that good stuff. There's your relative frequency. The histogram, there's no difference between a histogram and a bar chart. The only difference is a histogram, the boxes touch. To me, that's ridiculous. I don't care if you draw me a bar graph or a histogram. They're both bar graphs. I don't understand. Whoever came up with a histogram, that's about stupid, because they're both bar graphs. I don't understand the difference between the two. And if you use, well, the boxes touch. Well, that's not mathematical. That's aesthetics. That's just looking at it. That ain't, is a bar graph is a bar graph. I'm sorry. Let's see where else we got. Let's see if we got boundaries and class width and all that. They're getting there if they get through with relative frequency. Good gosh, y'all been doing percentages since 3rd grade. Ain't like they need help with that. Class width, there we go. Well, if they ever going to give you class boundaries or whatever, dot plot, I need to go over that, but not right now. Dot plot, scatter plot, dot plot. Well, I don't think we're ever going to get 2.3. I'm trying to get there. Hold on. Got 15,000 homework questions in the book. Oh my gosh. Finally. Okay, this is the section I was telling you about with bias, where I told you that you hand your report to the graphics department and they screw it up. Look for the oil barrels, OIL barrels, and the soccer balls. Let's see if they still put it in this book. Let me find the... Well, I'm getting there. Okay, there's a test question right there. So you might want to write it down. It's just the problem right here. You don't have to write word for word, but just write down the gist of that problem and make sure you kind of draw this picture, because this is a test question. This is a misrepresentation of graphics. It says soccer seems to be losing popularity as a sport in the United States. Duh. In 2010, there were approximately 14 million. By 2017, there was 12 million. Okay, now you could actually new minus old over old. For those of you that don't know this, new minus old over old. New minus old over old
Priority 1
and
message
multiply
coming in from
that
secure channel.
by 100, and that is the reduction or increase percentage. So 12 minus 14 over 14 multiplied by 100, that's negative 2 over 14 multiplied by 100, which is equal to negative 1/7 multiplied by 100, which is 100 divided by 7, and it's a negative. So 7 will go in there one time, 30 be 4, 0.2 be 3. Negative 14%. Does everybody understand what basically I'm doing? So how much did it drop nationally? 14%. Somebody tell me something. What's wrong with this picture?
It's negative.
No, the negative, it goes down. What do you mean negative? Tell me what you mean negative, Mr. Hamby.
I don't know. I was just taking a guess at it.
Look at the two soccer balls and tell me, since I gave you the reduction of 14%, right there, there's the population of soccer players in the United States went down 14%. What's wrong with these two soccer balls?
The smaller soccer ball is a lot smaller than the big soccer ball.
Okay. In other words, does this equal 14%?
No.
No. In fact, couldn't you fit this soccer ball into one of these black and white tetrahedrons or whatever you want to call them? Couldn't you?
Probably.
So there's 1, 2, 3, 4, 5, 6, 7, 8, and that black one with all the white remnants could be 9. This ball is 9 times bigger than this ball. Does 9 times equal 14%? No. So is this a good graphic or a bad graphic? It's bad. Thank you. That is a test question right there. Now there is another question. Oh, pie chart. Now I give y'all a bonus question. What is the weights of my class? Is it 30, 30, 30? Or is it 80, 20? Okay, 80, 20. Is it 80, 20? Or is it 30, 30, 30?
80, 20.
Why is it 80, 20? Why is it not 30, 30, 30?
Because 80, 20 adds up to be 100.
Because they don't equal what? 100. The pie chart question will ask you that. The pie chart question will ask you that, and it will be on the test. I'm trying to find it. I don't know if they're going to give it to you or not. Here we go. Here is your second test question on 2.3. Well, 20 and 20 is 40. That's 67. That's 79. That's 89. That's 92, 90, 91. And 8 is 99. So what's wrong with this picture? Doesn't equal 100. Now, if I added it up correct, let me do it again. That's 40. That's 67. That's 79. 89, 90, 91. 91 plus 8 is 99. So it should say in here that it doesn't equal 100. So a pie chart, that's another question. I'm trying to find the barrels, but I don't think they took the barrels out, I think. There they are. So it says in the problem, it says the U.S. Strategic Oil Reserve is a government-owned stockpile of crude oil. It was established after the embargoes in the 70s. That's in the 70s. We had one of the probably the third worst president in the United States in the 70s, late 80s, or early 80s, late 70s. He screwed everything up. Anyway, does this look like it says blah, 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 how many times larger, as well as offset reduction? Its oil reserves in 1977 and 2018, and 10.14 million barrels in 2018. Well, I don't see where they're given 1977. Where is the numbers for 1977? There should be a percentage somewhere. Well, anyway, how many? Okay, here it is. Look at the totals. So let's do this. 652 minus 7.5. $652 minus 7.5 divided by 7.5 multiplied by 100. Now, since it's decimals, I'm not even going to try it. So I'm just going to pull up my handy dandy. It'll take less time to just pull up the. I'm just going to pull this one up. All right, 652 minus 7.5 divided by 7.5 and multiply by 100. So 8,600% increase. 8,600% increase. Now you can look at 652 minus divided by 7.5. That's 87 times. 87 times larger. So if you looked at this, that pretty much is an accurate statement. That's an accurate graphic right there. You could actually argue that actually it's not big enough. Okay, you could, but anyway, that's why you got to be careful on your media. All right, we need to finish up. So I've already taken the roll. So it looks like to me that y'all should be ready for chapter 3 next week, because you are responsible now 1.1 through 1.5, and now you're ready to work on 2.1 through 2.3. Y'all have a great weekend, and I'll see y'all Tuesday. And please get some sleep. See ya.